We moved to Norfolk, myself and my family moved to Norfolk about 6 years ago into this old house. Was formerly a pub. It's a very linear house, just one room deep all the way along, so every room has either 2 or 3 outside walls. Old house, solid brick wall construction, very hard to heat, and we felt that our fuel bills were going to be extremely high, and that was borne out in the first couple of years. So our main consideration when we were looking at what potential improvements we could make to the house, our main consideration was how can we reduce our energy bill and at the same time potentially do something that's less damaging to the environment and the world's resources. Shortly after moving here, as I say, we did the roof. The next thing we did, the porch that I built 3 years ago, I built because there was no porch, it was just open to the outside from the front door, and we were losing a lot of heat every time the front door was opened. We had nowhere to put coats and boots as well, and it was a relatively cheap thing to do to buffer us against the cold in the winter. So that was quite a good step in my opinion. As for the insulation, I did get a grant for that, and that's now insulated to the current building reg specification of, I think it's 300 millimeters. That immediately had a positive effect on the heat retention of the house. We had an old oil-fired Rayburn that was extremely inefficient, extremely thirsty, and probably coming towards the end of its life. It was rattling a lot and so on. So we considered what our options might be. We ruled out underfloor heating on the grounds that A, it was too disruptive, and B, the cost. At that time, it would have cost us probably between £10,000 and £13,000. So that left us with a straight choice between an oil-fired boiler, probably costing maybe £1,500, or a wood pellet boiler. And I was particularly interested in that because it burns a renewable source of energy, wood. Wood pellets are made from waste product from the timber industry, so it's a recyclable material as well. We would be off fossil fuels, and also because boilers these days are very much more efficient, I was looking for cost saving as well. This is our wood pellet boiler. I would class it as a semi-automated technology, not fully automatic. So it's not completely akin to an oil or gas-fired boiler, but it would be more automated than, say, a log-fired boiler or a wood burner. We load pellets into the hopper about twice a week. On the control panel here, we program in what time we want it to come on in the morning, what time we want it to go off, and again in the evening. It responds to a thermostat on the wall over there, and it turns itself on and off as it's programmed to do. The pellets are augured out of the main hopper, and they flow down this chute and into what's quite a small hearth really, and then there's a forced air current that makes sure that they burn extremely efficiently. Efficiencies are reckoned to be about 90 to 92%. One consideration if you do go for a pellet stove is how you're going to store your pellets and how you're going to take delivery of them. There's 3 basic ways. One is to have a big hopper which a tanker will blow pellets into, and that's obviously a very automated type of system. Second possibility is to have them delivered in what I call a dumpy bag, which is about a ton at a time, and then you have to find a mechanism of transporting them to your burner. The third option, which is the one we've gone for, is to have them delivered in bags. So we have a ton of pellets delivered at any one time in 10 kilogram bags, 100 bags, and you then have to have somewhere to store them, which is where we are now. Ideally, I think in the future we will probably move to more of a bulk system so that we can avoid having to handle the plastic. So what we have behind me is 4 panels on the main roof of the house. The 2 large ones carry fluid, well, water. They pick up the sun's energy, heat up the water, which then circulates back to the hot water cylinder in the airing cupboard, gives its energy over to the water in the airing cupboard and heats the hot water during the summer months. The two small panels are photovoltaic panels, and they actually drive the pump that circulates the water. The array behind me faces due west, which isn't ideal for solar panels, but it's perfectly adequate. What I've had to do is to just oversize the array slightly, so it's bigger than what you would need if it was facing due south. But since the sun's energy is free, once you've bought your panels, there are no associated extra costs in terms of running. On a hot day, or a very sunny day like today, these get the water in the cylinder up to about 80 degrees centigrade, which is obviously extremely hot and potentially dangerous. So we then mix it back down to about 55 or 60 with a mixing valve in the airing cupboard. On a cool day or a cloudy day, it may not get above 30 or 35 degrees C, which means that we have to then boost it with the immersion heater. We have 10 panels on the roof. Each of them is 215 watts peak, so it's 2.15 kilowatts when it's working at full pelt. They feed direct current into this machine, which is called an inverter, and this transforms it from DC at 12 volts to AC at 230, 240 volts nominally, and from there it either gets used in the house if we're using some current using device, or if not, then it gets exported to the national grid. And at the moment, you can see on the display, although we've got a potential capacity to generate just over 2,000 watts, we're actually doing 500 watts at the moment because it's a slightly dull day outside. The panels are very sensitive to shading out. We do have some shading issues here, and one mustn't ignore those when one considers whether you've got a suitable roof for solar panels. When they're going in full sun, if you were to hold so much as a table tennis bat against one corner of the panels, you would find quite a dramatic drop in the output. It's a bit like putting your toe on a garden hose. Only on a small piece of the hose, but it dramatically affects the output of the water at the end of the hose pipe there. So the panels have generated about £720 for us in the first year of the feed-in tariff, which represents a return of about 7% on our capital investment, which by any standards is quite good. I would say our level of comfort is much improved, mainly on account of the loft insulation and the porch. The technologies have improved our cost savings and improved where we consider our interface with the environment is. When we consider the porch, the insulation, the boiler, the solar photovoltaics, the solar thermal, we might be looking at about £20,000 of investment, but we consider that's money well spent. We're already recouping some of that money in terms of either savings in energy usage or in terms of feed-in tariff from the government. I myself am self-employed, so it was an investment for the future as well. We're looking at technologies that hopefully will last towards my retirement at least. It doesn't have to be high expenditure, high investment type of technology. I would say if you were to strip it away, insulating the loft space and putting the porch on have probably been as important as changing our boiler and adding panels, solar panels to the roof. So I'd encourage everybody to at least consider what their options might be.